is Dr. M. Vairalashmi, working as Assistant Professor of Chemistry, V.V. Vaniya Perumal College for Women, Virudhunagar. The topic I have chosen for today is hydrogenation of olefin from the chapter Organometallic Compounds. Okay, hydrogenation of olefin is an industrial important reaction because it is used in both petrochemical as well as pharmaceutical industries. The successful catalyst for this hydrogenation of olefin is Wilkinson's catalyst, that is chloro-tris-triphenyl phosphine rhodium complex. Okay, so this is a Wilkinson's catalyst. It is a homogeneous catalyst in the aromatic hydrocarbon medium such as benzene or toluene. Okay, so this Wilkinson catalyst is very important because it catalyzes the hydrogenation of olefin in a specific manner. Yes, it catalyzes the hydrogenation of olefin in a specific manner. It catalyzes the hydrogenation of particular double bond. Okay, so this is an overall reaction. This is our olefin, that is ethylene. It is added to hydrogen molecule is added to this olefin in the presence of this Wilkinson's catalyst in the benzene medium. Hydrogenation takes place. Here this hydrogen bond gets glued and it is added to this carbon-carbon double bond and we are getting the alkane. So here alkene is converted into alkane by this Wilkinson's catalyst in the benzene medium. Okay. Let us see the importance of Wilkinson's catalyst. Okay, so I already told this Wilkinson catalyst is catalyze the hydrogenation of olefin in a specific manner. Secondly, this catalyst catalyzes the hydrogenation at room temperature and nearly atmospheric pressure. Okay, so there is no need for using utensils capable of withstanding high temperature and pressure. Okay, so these are the importance of Wilkinson's catalyst. And let's see the role of this rhodium metal in the catalytic process. Okay, so first it provides the low energy path for leaving HH bond in hydrogen molecule. Okay, so it reduces the activation energy. Okay, so it reduces the energy barrier for hydrogen molecule. So it provides the low energy path for the hydrogen HH bond cleavage. Okay, then secondly, this rhodium coordinates with alkene, thereby weakening of bonding between the carbon atom of olefin. Okay, so secondly, it weakens the carbon double bond carbon of olefin. Okay, so the third role of this rhodium metal is it provides the mechanism for transferring two hydrogen atom to the olefin carbon atoms. Okay, so let's see the mechanism of transferring these two hydrogen atom to the olefin. Okay, so this is the overall mechanism. So this is our Wilkinson's catalyst. Here triphenyl phosphine is simply represented as L. Okay, so this is rhodium. There are 3 triphenyl phosphine and 1 chlorine. Here the oxidation state of rhodium is +1. Okay, so there are 3 neutral ligands. Triphenyl phosphine is a neutral ligand and chlorine is a negative species. It is a univalent ion. It is a negative univalent ion. So the charge of chlorine is -1. Obviously, the oxidation state of this rhodium is +1. Okay, so the first step is the reversible loss of 1 triphenyl phosphine molecule. Okay, so here 1 triphenyl phosphine is removed by the solvent molecule. So it is the reversible loss of 1 triphenyl phosphine by the solvent molecule. Here also the oxidation state of this rhodium is +1. Okay, so in the next step oxidative addition takes place. Okay, so here oxidation and addition reaction, both the two reactions takes place in a single step. Okay, what is oxidation? Oxidation is nothing but removal of electron. Okay, here 2 electrons are removed from this rhodium metal. Okay, so 2 electrons are removed from this rhodium metal and also this hydrogen atom are added to this metal. Okay, there are two hydrogen atom are added to this metal, so that is addition, and here oxidation takes place. The oxidation state of rhodium is converted into +3, so +1 is converted into +3, so 2 electrons are removed from the rhodium metal and it is donated to 2 different hydrogen atoms. Okay, so obviously each hydrogen atom having one single electron, so the rhodium metal provides 1 electron for each hydrogen atom, so there will be a formation of one single bond. So this is addition. So here both oxidation and addition takes place in a single step. So this type of reaction is called Oxide reaction, oxidative addition, that is Oxide reaction. Okay, so in the next step, that is third step, addition of olefin takes place. Okay, so here the olefin is added to this Wilkinson catalyst. Okay, so it will form the metal olefin pi complex. Okay, here this rhodium plays 2 important role. The one is it weakens the carbon-carbon double bond. Okay, the first one is it weakens the carbon-carbon double bond. Okay, so the second role of rhodium is it brought this olefin carbon atom and also hydrogen atom into a close proximity. Okay, so these two are the major role of this rhodium metal. Okay, so in the fourth step, insertion of olefin takes place. Here this olefin is inserted into this metal hydrogen bond. Okay, so here olefin is inserted into the metal hydrogen bond. Okay, so it will form the metal alkyl complex. Okay, so here metal alkyl CH2 CH3, so it will form the metal alkyl complex. Okay, here this olefin is inserted between this rhodium and this hydrogen. Okay, so here hydrogen is added to this carbon. Okay, so it will form the metal alkyl complex. Okay, so in the next step, addition of solvent takes place. So it will form the solvator complex. Here there is no change in the oxidation state of rhodium +3. After the solvation, also the oxidation state of rhodium is +3. Okay, so the next step is very important step, that is reductive elimination. Here reduction and elimination takes place in a single step. Okay, here this rhodium is reduced from +3 oxidation state to +1 oxidation state. Okay, and also the coordination number of this metal complex is 6. Okay, so coordination number is changed from 6 to 4. Okay, so here elimination occurs. Here which compound is eliminated? Here this hydrogen is transferred to this olefin and it will form the alkane. Okay, so this is our product. This is the alkane. So here olefin is converted into alkane. So the remaining byproduct is our original catalyst. Here the coordination number of this complex is 4. So here the metal oxidation state is reduced from +3 to +1 and also elimination takes place. Here these two groups are eliminated as our product, that is ethane. Okay, so in this way we can synthesize the ethane from ethylene. Okay. So next we can see the disadvantages of this Wilkinson's catalyst. Okay, even though there are so many advantages of using this Wilkinson's catalyst in the hydrogenation process, but some few disadvantages also there. The first one is it is a soluble catalyst. Okay, so while it is soluble catalyst, we cannot easily remove the catalyst after the completion of the reaction. So it is a major disadvantages of this Wilkinson catalyst in the hydrogenation process. And the next one is, due to high cost of rhodium, this Wilkinson catalyst is highly expensive. Okay, so to rectify the disadvantages of using Wilkinson catalyst is by the modification over the catalyst. So we can modify the catalyst. So we can modify the catalyst and we can easily remove the disadvantages of this Wilkinson's catalyst. How we can modify? Okay, so this Wilkinson catalyst, that is soluble catalyst, is converted into insoluble catalyst by building the catalyst on the insoluble solid support, such as polystyrene, polyvinyl chloride, and the silica. Okay, so these are the polymeric material. Our Wilkinson catalyst is supported on the solid surface, means we can easily remove this Wilkinson's catalyst after the completion of the reaction. Okay, so this is the hydrogenation of olefin by the Wilkinson's catalyst. Okay, thank you for watching.